So today we're going to focus on the concept of density. And sometimes people think of density as being how heavy an object is. But it's more than that. It's really how much stuff is in a certain amount of space. And two objects that have the same size, if one of them is heavier than the other, then that one is more dense. So for instance, I have a block here of brass and one of pine. They're the same exact size, but you can hear the difference in their weight. That's the brass and that's the pine. So we know that this one is more dense than this one, but what does density really mean? So density is the amount of stuff in a certain amount of space. So if we have stuff, and this is going to be our stuff, this is going to be our particles, our stuff, that's what we're going to call it for now. If I take all of this stuff and I put it in a certain space and compare the amount of stuff to the amount of space, that's what density is. So I'm going to take all this stuff and I'm going to put it in this beaker. And because there's a large beaker, a large space, there's a lot of extra space. This is not very dense. There's a lot of space. If these particles were moving around on their own, they would have lots of space between them. But if I take the same amount of stuff and I put it in a smaller space, like this, then now we have some space between the particles. They could move around a little bit, but it's more dense because there's a smaller space. Same amount of stuff, smaller space. Now, if I take the same amount of stuff and I put it in an even smaller space, and hold on, I can get it in there. I have to cram it together to get it to fit because it is a smaller space. So I have to push that together. It's like when you have an overflowing trash can, right? So now I know that there's less space between these particles, making this more dense. So this is the least dense, this is the most dense, and that's because the space is smaller, but the amount of stuff is the same. But the opposite is also true. So if I had more stuff and the same amount of space, it would also become more dense. So we're going to add even more stuff. So I know that this is already pretty dense. I've had to squish it to get everything in there. But if I take more stuff and I keep packing it in there, it becomes more and more dense to the point that I don't know if I can pack any more in there. But maybe. So this is more dense because now it has more stuff, even though it was the same amount of space. Hopefully that kind of makes some sense. But in science, we don't really use the terms stuff and space. We use mass and volume. So density is a comparison of the mass of an object and the volume of an object. So we know that the mass of an object is actually the amount of matter that an object contains. That's what mass is. Volume is the amount of space an object occupies. We can calculate both of those things. We use a triple beam balance to find the mass, and we use either the formula length times width times height to find the volume, or we can also use something called water displacement, but we're going to get into that a little bit later. For right now, what we need to know is that density has a mathematical formula. And that mathematical formula is mass, or stuff, the amount of stuff, divided by volume. Mass is going to be measured in grams on the triple beam balance. So we have grams. And volume is going to be measured in cubic centimeters because we're going to focus first on solids. So cubic centimeters is just a measure of solid volume. Like this has a certain volume and we'll measure it in cubic centimeters. If we were measuring liquid volume, it would be measured in milliliters, but we're not going to worry about that right now. So in order to calculate the density of an object, you have to have those two pieces of information, mass and volume. And I'm going to quickly run through how we do that so that you can see how it works, and then we'll get more detailed later. So I'm gonna take my triple beam balance, and you should know already how to use a triple beam balance. We make sure that it's set all on 0, and we start with the largest beam, the second largest, and then we get very detailed with the small beam in the front. So we're gonna find the density of this block. This is actually made of brass. So we're gonna place it on the balance, and we're gonna use our largest beam first, and ooh, too much. So we're gonna go back to the 100. We're gonna go to 20, 30. Oh, 40 is too much. So far we have 130 grams. But now we're gonna try this front beam. We get it to balance at 138 grams. So we know that the density of this block is mass divided by volume, and we know the mass now is 138 grams. Now we need to know the volume, and to do that, we're going to use the mathematical formula length times width times height. And it doesn't make any difference what you call the length, the width, or the height. It makes no difference at all. All you have to do is find the 3 measurements and multiply them. Make sure that when you use your ruler, you're using the centimeters, not the inches, because that won't work. And we're going to carefully take 3 lines of measurement. This block is easy because they're all actually the same, but that's not always going to be the case. So we have 2.5 times 2.5 times 2.5. So we're going to use our tiny baby calculator. 2.5 times 2.5 times 2.5, and we get 15.625. 15.625 cubic centimeters. It's not centimeters because it's not a flat line. It's 3-dimensional, so we measure it in cubic centimeters. So now we have all the information we need to actually figure out the real density of this block. The density is going to be 138 divided by 15.625. And that gives us a density of 8.832. Now, here's where we run into a little bit of trouble. Grams and cubic centimeters are not the same thing. We can't divide grams by cubic centimeters. So we actually leave it exactly the way it is. Grams per cubic centimeter. So the density is 8.832 grams per cubic centimeter, which actually makes sense because it's the stuff in a certain amount of space, and that's what density is. Density is the comparison of how much stuff or how much mass is in a certain amount of space or in a certain volume.